Hi everyone, and thank you for signing up for this TÜV SÜD webinar on chemical management and the Detox program. So before we start, here's a quick introduction of our speaker today. We have with us Dr. Raymond Lui, who is the Vice President for Business Solutions, Chemical Testing and Certification, and is also the Global Service Line Manager for Non-Food Chemical Labs in TÜV SÜD. Dr. Liu has over 20 years of experience that covers a broad range of interrelated topics with a strong research focus on fabrication and characterization of exotic materials. His key responsibilities are to manage and grow the business line for the retail sector in TÜV SÜD. Finally, he holds a postdoctoral fellowship in chemistry, electrical and electronic engineering, and as well physics. With that, I will now hand the presentation over to Dr. Liu, who will kick off with an introduction to the chemical management and detox campaign topic. Dr. Liu, go ahead.
Okay, thank you very much. Welcome everyone. This is Raymond speaking. The topic of presentation today is about chemical and chemical data management and also the relationship between these two kinds of management and the detox program. Yeah, here is the content of the presentation of today. First of all, we will have a very brief introduction. We will talk about the behind motivation about the management and also the detox campaign. And then we will switch to discuss about the explicit requirements and the concepts of chemical and chemical data management. The explicit requirements are actually how we are going to address the requirements of the Greenpeace and also the Zero Discharge Hazardous Chemicals Foundations. And then we will go to the topic about the chemical audit and wastewater and sludge testing. Actually, these are the audit work and also the testing work we need to fulfill in order to comply with the requirements of Greenpeace and also CDHC. Then we will introduce the IT platform, what we call the Intelligent Database CDMS, and how the two new approach will be employed in order to do the chemical data management, namely the bomb-oriented testing and also the quantitative risk assessment. At the end of the presentation, we are going to have a summary. Okay. So before actually dive into the actual content, there are some keywords I would like you gents and ladies to bring home. The first one is about the explicit requirements of the detox campaign. Everybody knows something about the detox and also CDHC already. But in this presentation, we address explicitly what will be the contractual terms we have to agree with the Greenpeace in order to deal with the detox campaign. And then we will talk about the quality system on chemical management and testing. We try to differentiate the concept between chemical management and chemical data management. Yeah, just like any quality system, we will talk about the plan, do, check, act cycle. And also the chemical audit, which is a very important part of the quality system. And then we will also talk about the screening of chemical formulations, because we know that when we test on the wastewater, this has helped us to find the gap between the quality system and the implementation of the quality system. And then actually to address the problem at the origin, we have to take care of the use of chemical compounds. So that is why we talk about the screening of chemical formulations. Then we will introduce two new concepts, one called the smart testing, that is about how to test. And another one is about the sensible testing, is what to test. What to test means, are we going to test 100% every single time on the final product? Yeah, and then we will introduce the concept of the bomb-oriented testing. We will differentiate the concept between bomb for manufacturing and bomb for testing. And then last but not the least, we will talk about the quantitative risk assessment and the risk curve. The risk curve is an IT algorithm helping us to calculate the passing probability of chemical testing for a particular piece of material for a particular suppliers. And then we will show a 2-minute video on the Intelligent Database CDMS. Now it is the introduction part. So why do we need to have the chemical management and chemical data management? This is because we all know that testing is not the ultimate goal for most of the international legislation. Say, for example, REACH, because in REACH we are targeting more than 2,000 different kinds of chemical analytes. And it is not managing the abuse use of the chemicals. If you refer to the REACH regulations, actually on Chapter 1 is spelled out very clearly. It is about the management on the use of the chemicals. It's not about testing. And the second consideration is about it is actually not affordable not only in terms of money, it is not affordable in terms of time and the sample amount. If we are going to test like 2,000 different chemical analytes on a very small piece of materials. So, and if we also know the amplification of costs, if we would like to rework on any problem done along the supply chain, it is better for us to manage the problem at the origin, that is at the upstream of the supply chain. So these are the behind motivation. With all this motivation and rationale, we strongly believe that the future direction is about chemical and chemical data management along the manufacturing, along the chain of manufacturing. So it is all about the setting up of a quality system. It is all about the design of the system and how to implement the system. And we will go through the whole quality cycle like plan, do, check, act. And then we will promote the testing at the upstream of the supply chain. So that is why we promote the testing away from the final product to the raw materials and all the way up to the chemical formulations. And then we will promote the use of the quantitative risk assessment in conjunction with the spot testing in order to make sure to uphold the quality of the production of the final products. And it is all about the supply chain and supplier pool management. Yeah. So we come to the explicit requirements of Greenpeace. And then when throughout of our discussion about the explicit requirement of the detox campaign, you will understand that it is all about communication and transparencies. So we will go in to this explicit requirement one by one. Actually, all these requirements could be found on the web when some of the brands or famous retailers sign up the contract with Greenpeace. We consolidate all this information in this presentation so that you could know what kind of requirements are actually you need to take care in practice. The first one is about the supply chain disclosure. Disclosure, that means transparencies. The action number one is about you have to publish the combined MRSL by adopting the lowest reporting limit that are technically achievable together with the testing methods. So that means you have to publish not only the RSL. RSL stands for the restricted substance list, which we use very often on final product testing. But now you also have to publish your requirements on the use of the raw materials and chemical formulations. And with the combined MRSL, that means we have to publish as well the roadmap, how we are going to achieve the limits targeted by Greenpeace by 2020. So this is about your plan, how to reach the goal. And then the action number two is to disclose the hazardous chemical being discharged by the suppliers. That is about the current status. Very often, most of the empires have a lot of suppliers, hundreds of them. So we need to put down a date by which you will disclose the current status on the use of the hazardous chemicals by at least 50% of your suppliers. And then you also have to put down a second date by which you will reveal all the information for more than 80% of your suppliers. And the disclosure of the current status will have to be published on public platform, say, let's for example, IPE, which is a public platform in China for you to publish the audit and testing results of the factories. Yeah, by adopting the corporate discharge disclosure data form, that means that we have a standard template for you to disclose your data on this public platform. And then we have to make sure all the data and the information disclosed on this public platform are genuine and not misleading. Yeah. And then the second requirement is about the 11 groups of hazardous chemicals. We have to eliminate the use of them. The first one, of course, once again, we have to publish the investigation results on the current level of compliance. So once again, it is about communication and transparencies. What are the current status? And then action number two has to be taken by the empire is to strengthen the contractual language to their suppliers on the elimination of the use of these 11 groups of chemical formulations. So this is something this is an action has to be taken by the empires in order to make sure with due diligence on the elimination of this 11 group of chemical analytes. And then On the testing side, we have to adopt the lowest possible testing regimes. So that means we have always to use the state-of-the-art analytical instrument in order to test for the presence of these 11 groups of chemical analytes. And this is very important because if we are talking about the lowest possible testing regimes, that is the use of the state-of-the-art of analytical instruments, that means there is an impact on the financial side when we conduct the testing, because no longer composite testing is possible. Then it needs us to think about how we are going to manage the chemical use and also the chemical testing data. Action number 4 is about to showcase how we eliminate and substitute the use of this kind of hazardous chemicals. And we have to publish once again on a public platform. An example of this public platform is called sport.org. So whenever an end buyer, together with their suppliers in an industry, if they succeed to find a replacement for hazardous chemicals, they are highly encouraged to publish these results on a public platform. Yeah, and explicitly, the Greenpeace are very much focused on several kinds of hazardous chemicals. The first one will be the PFC compounds. So once again, it is about the elimination of the use of the PFC before aluminum day. Yeah, and this, action number 2 is about to document how PFC is substituted by another alternative. And once again, we have to publish this result on a public platform. Action number 3 is a rigorous system on the control, how to make sure there will be no PFC used along the supply chain. And action number 4 is about the working partnership within the supply chain and within the industry to accelerate the elimination on the use of the PFC technology. Yeah. So once again, you could see it is about communication and also about transparencies, and work together within the industry to eliminate this group of chemical compounds and publish the result on a public domain. Very similarly, it is again applied to APEO, elimination policies. Once again, you have to publish the current level of compliance, so that is why we have to do the testing, and also we have to do the audit and publish the result on the public domain. And then once again, we have the end buyers have to strengthen the contractual language with their suppliers to perform their due diligence to eliminate the use of this kind of chemical compounds. And then again, work with the supply chain and the global industry to ensure most of the current limits of the detection in the testing work. So that means we are driving the limit of acceptance of testing this kind of compound to even lower values. So this, once again, I have to emphasize, if we are doing like this, that means there will be a financial impact on the testing costs. And once again, it needs us to think about how we should manage our chemical data and the use of chemicals. The action number 4 will be to document how APEO is substituted by safer alternatives, and once again, published on the public domain. Okay. Number 5, it is the 5th requirements. It's about the target other hazardous chemicals. Of course, right now we are talking about 11 groups of hazardous chemicals. And actually, this 11 group of hazardous chemical has been expanded to 14 or 15 groups in CTHC Foundation. Yeah, but we are not only targeting these 11 groups. We are also targeting other hazardous chemicals. So that is why, once again, the end buyers has to work together with the suppliers to put down the MRSL or the combined MRSL together with a roadmap to eliminate all the hazardous chemicals in the supply chain. And then the requirement number 6 is about the responsible design through a closed-loop operation across the global supply chain. So this requirement is all about the design with a perspective about the environmental safety, which is about the use of environmental friendly materials through a business model like EPR. The EPR is simply about recycle, reuse, or buy back the materials at the end of the product life cycle. And by using the recycled materials to manufacture, once again, the final products. And then another approach will be to initiate a global sustainable consumption program, that is to eliminate the use of disposable final products and to encourage the manufacturing of apparel and footwear or other consumer products which are more long-lasting. Yeah, and then the end buyers, together with the supplier, has to come up with a program by a nominal day to launch this kind of sustainable consumption program. Yeah. Okay, and requirement number 7 is about the self-reporting on the detox commitment. The action to be taken here is about a proactive report to the public, essentially on the regular detox finding on IPE, let's say that is to publish the audit finding and the testing findings, and then by some nominal days to publish the case studies on the .org. That is all about finding a good, safer alternative to the hazardous chemicals, and publish and showcase your success stories, and then outline the approach to eliminate the presence of hazardous chemicals in the supply chain. So in summary, you could see that all these action items or all these explicit requirements required by Greenpeace is about communication, transparency, and publish your success stories. Yeah. So with all these explicit requirements, when you're about to sign a contract with Greenpeace, we could discover some specific goals. The first one is you have to create a combined MRSL, together with which there should be a roadmap for the MRSL. Combined MRSL once again stands for the Manufacturing Restricted Substance List for chemical formulations, for raw materials and wastewater, and also sludge, while RSL stands for the Restricted Substance List for final products. Yeah, and then you need to have a quality process together with an IT system to monitor the supply chain for the partial fulfillment of the contract to be signed with the Greenpeace. Yeah, why it is so? Because we are talking about a roadmap, and we are talking about the elimination policy, and we are talking about driving the testing limits to the state of the art of the analytical instruments. So we need to have a good quality process in place with good traceabilities. And in order to fulfill all these requirements, there is a necessity to have an IT system in place. Yeah? And then another specific goals will be a quality process and IT system to allow the smart testing, which is about how to test. How to test means, are we going to do the full quantitative analysis all the time, or we could develop kind of cost-effective screening testing in order to screen for the presence of these hazardous chemicals. And it is also about the sensible testing. That is about what to test, together with the quantitative risk assessment. If we are talking about the testing at the raw material stage or all the way up to the chemical formulation, are we going to test 100% all the time at the final product stage? If the answer is no, then we need to have an IT platform together with a quality process in order to uphold the quality assurance along the supply chain. Yeah. And then the last specific goal will be a quality process together with an IT system to allow to set the KPI of the suppliers, and then to do the final and then to do the evaluation, performance evaluation accordingly. Setting the KPI is to help the suppliers to bring them back on track in order to fulfill the requirements of Greenpeace. Yeah. Okay. Now we switch to the topic about the chemical management, because at the beginning of the presentation we also manage in the future. It is all about chemical management and chemical data management. So we switch to the topic of chemical management, which is important in concepts, but this is more relevant to the factory. So that is why we briefly touch this topic. Chemical management is about the establishment of a quality system. So this is the plan of the plan, do, check, and cycle. It is about the establishment of a quality system, which is to document all the information to allow very effective distribution, which is also about the traceability and also to raise the awareness along the supply chain. It is also about to standardize for the sales, for the safe and regulated practice, and to monitor for preventive control by measurable objective. So this is all about the planning phase. And then the do phase is about the implementation of such a quality system in the whole manufacturing process, and in particular in the factories. And then it comes to the check part. That is why we have the external audits. So this is about the pre-audit for the gap identification and analysis. And at the end of the day, after we have performed the audit to find out the gap, then it will be the healing process. And it is about ACT. That is to offer the healing plans to close any gap. So this is all about the chemical management. Yeah. Then what is about chemical data management? It is all about the analysis to be performed on the data in order to get the business analytics. It is also about the transparency and traceability along the supply chain. So the chemical data management, to be differentiated from chemical management, it is about the consolidate all the production information along the supply chain. In particular, we are talking about the bill of materials and also the bill of substances. So you need to have the bill of materials to put down line by line the material component to be used to manufacture your final products, as well as the bill of substances, that is the chemicals, to facilitate the production of your final products. And we have to make sure there is a traceability along the supply chain from the raw material stage to the final product. Let's say if we have a kind of chemical formulation, let's say pigment, into the manufacturing process, we need to have the full traceability regarding who is the supplier, what will be the ingredients in this kind of chemical formulation, and if it consists of any of the hazardous chemicals we talked about earlier. Yeah. Similarly applied to the raw materials, we need to have the full traceabilities down to the lot of the production. And then we have to compile up-to-date requirement of the regulation on chemical by materials, by usage, and also by region and countries. Because as we know, even though for United States or for EU, especially for EU, we have the EU guidelines at the very high levels, and we also have to pay attention to the national deviation. This is particularly true if you have any product which is to become in contact with food. Then you will know, actually, besides the EU guidelines, general guidelines, you also have to observe the national deviations. These are very important information, so that when the producer try to export their product to these countries, they have to know what kind of limits or what kind of regulation they have to comply with. And then this chemical data management is also about the easy access of the MSDS, the RSL, and also TDS. MSDS stands for the Material Safety Data Sheets. If we talk about Detox or CDHC, MSDS is the very first document we will look into when we perform our audit. RSL, that stands for the restricted substance list, or in the future we will talk about an MRSL or even a combined MRSL. It is about the hazardous chemicals which are forbidden to be present in the material and also in the final product. And it is also the testing requirement of most of the end buyers. TDS stands for the technical data sheets. Yeah, all these documents have to be made available to all the suppliers along the supply chain, or to all the stakeholders along the supply chain for risk assessment and also for precautionary actions and phase-out plans of the hazardous chemicals. And this chemical data management will help you to formulate the test plan to reduce redundant testing. Earlier we talked about if we test on the raw material stage and also even up to the chemical formulations, we may not opt for testing 100% on the final product level. That if we are going to exercise this, then we have to use the IT platform together with a quality process. And then we will have to formulate we will formulate the test plan to monitor the reduction and elimination of restricted substances. At the end of the day, we would like to set the KPI for the supplier along the supply chain and then do the quantitative evaluation on their performance. Yeah. So this is all about the chemical data management. Yeah. So the first topic we are going to talk about is the chemical audit and wastewater and sludge testing, because everybody knows this is one of the requirements of the Greenpeace as well as CDHC. You have to test on the wastewater and the sludge. But I have to emphasize here is to test on the wastewater and the sludge as well as to carry out the audit is the check of the whole plant do check at cycle. The aim of doing so is to find the gap. Yeah, once you find the gap, we still have to do the CAPA, that is the corrective action and preventive action, that is the healing plan, to address the problem at the very origin. Yeah. Okay, so talking about the audit, right now TÜV SÜD is a member of the CDHC, so that is why when we perform our audit, we adopt the full checklist of the CDHC Foundation. But talking about this audit, essentially it is about the audit on the management system, on the environmental management system, on the process control monitoring system, the store management, as well as the waste and wastewater, and also the sludge management. These are the essential topics for the audits, and we adopt the CTHC Foundation checklist. Another criteria will be the testing, because we all know we have to test on the wastewater and the sludge, and it is all about 11 groups of hazardous chemicals. So when we perform the audit, we focus on the management system, and we also focus on the result of the testing. At the end of the day, we combine these two results together to give a final grading. Yeah. So this is the principle of the audit. Yeah. And then once we have the final grading, we will categorize the factories into different grades, and different grades represent different risk levels. Say, for example, for grade 4, it means the finding from the audit together with the testing indicate therein in the factory we have a satisfactory implementation and carrying out of the management system, as well as of very good testing results on the hazardous chemicals from the wastewater and also from the sludge. Yeah. This is a schematic diagram about the wastewater and sludge testing process. It is extracted from an ISO standard. It gives you an impression about how we are going to conduct the wastewater testings and sludge testing. The most important thing is about communication in parallel. Because for wastewater testing, we are talking about testing limits down to the ppb levels. And then very often we have to go to the open site of the factories. So communication between the factory and the testing host, as well as with the logistic partner, is very important. And not to mention, because we are talking about ppb level testing, all the sampling, that is all the water sample and also the sludge sample, has to go back to the factory, go back to the laboratory within 24 hours. So that is why the logistic is also very important. And this schematic diagram, this flow chart, is for your reference. Yeah? Yeah? And then we would like to emphasize once again on the sampling matrix and also the location of sampling. Why we would like to emphasize this? Because very often most of the end buyers, they choose to test on the wastewater only after the wastewater treatment. And actually, if it is for us to have any meaningful CAPA action when we find something in the wastewater, we suggest the following. We suggest to test the wastewater, we suggest to test the incoming water of the factory. We suggest to test on the wastewater before treatment and also the wastewater after treatment. Only with all these samples and the experimental findings on these waters, we will be able to construct a CAPA meaningful enough to rectify any unfavorable findings from the testing results. Yeah. Then it is also about the sampling strategies. Okay. Well, very often we sample the water in different time intervals. We call that composite testing. We composite the wastewater. We sample at different time intervals in equal portions, so that the final sample represents the general performance of the waters. So it is again before the wastewater treatment and also after wastewater treatment at different time intervals. Yeah, this is also once again for your reference. Yeah, and then it is all about QA/QC procedures. As I mentioned earlier, when we talk about wastewater treatment, we are going to talk about limits down to the PBB levels. So that is why QA/QC procedure is very important in wastewater testing. And in the following several slides, I tabulate some of the QA/QC procedures for your reference. For example, we have a lot of blends. When we do final product testing, actually in the laboratory, we also have blends in order to see if there is any background noise in our experimental data. And this is especially important in wastewater testing because any cross-contamination in the field or by the use of the instrument during the sampling process, or the cross-contamination in the laboratory will already mask the true findings from the wastewater. So that is why we have very complete QA/QC procedures in place. I'm not going to spell out all the details from these slides, but it offers you a very good reference on how the QA/QC procedure should be conducted during the wastewater sampling process and as well as on the testing process. Yeah. Okay. And it is also very important to emphasize during the transportation, we have very special measures in place to make sure there will be no cross-contaminations. First of all, the samples are appropriately labeled and packed to avoid breakage and cause contamination. We will reduce the sample degradation by appropriate preservation. That means we do not only sample the wastewater, but during our sampling process, we will also add the chemicals to do the preservation. And then the time between the sampling and analysis does not exceed the holding time. We will have more about the holding time later. But as a rule of thumb, we have to send all the sample back to the laboratory within 24 hours. And also the sample containers should be sealed, carefully packed with packing materials, and all the sample has to be chilled between 0 to 4 degrees Celsius in a cooler bag or in a fridge. That is to prevent the degradation of the chemical analytes in the wastewater. Yeah. So talking about the container preservation and holding times, I consolidate some information in the following few slides as a very good reference, to you. Especially you may like to check, okay, how about if I would like to test for heavy metals, how the testing house perform the testing on the heavy metals, what kind of container they are using, any preservative they add, and what about the holding time. So you could have all this information in these several slides. Yeah. Okay. Okay. So now, also very important on the QA/QC procedure is when you receive any testing report from the testing house, there are 3 attributes you may like to check on the report. The first thing is about the duplicate sample. It is about the reproducibility of the testing. Basically, it is to test on the same sample more than one time in order to see if there's any deviation. As a rule of thumb, the deviation should not be bigger than 20%. Another thing is about the spike recovery. That is, we spike a known amount of concentration of a particular hazardous chemicals into a sample, and in order to see what is the recovery rate. And the nominal recovery rate should be between 80 to 120%. And the last but not least, it's about the blend samples results. As I mentioned before, this is about the background. If the background is already higher than the testing results from the wastewater, that means the whole testing process should be questioned, and the result is no longer valid. So in the report, you should find the blend sample result. It should be at the undetected levels. Okay. Then talking about the geographic distribution of the chemical testing map of TÜV SÜD, as you could see on this map, we have our operation in South America, in Europe, in South Asia including India and also Bangladesh, and also in Asia. In Asia, we have operation in China, of course, and also in the ASEAN countries like Singapore, Vietnam, and Cambodia, Indonesia. We also have our operations. And then talking about the competence matrix of all these non-food chemical testing laboratory, there is a tabulation of the competence. Just to pick up a few examples, let's say we have operation in the ASEAN countries, in Singapore, and then you will see all the abbreviation on the competence matrix. SFL stands for soft line. That means this laboratory dedicated to soft line testing, dedicated to material coating testing, and also environmental testing. So whenever you have seen a lab with the capability to do environmental testing, that means it is capable to handle the testing required by Greenpeace and CDHC. So as I mentioned, SFL stands for soft line, HDL stands for hard line. Hard line means E&E product or hard goods product like kitchenware, blender, coffee machines. And then TCP stands for toys and children products. And then FCM stands for food contact materials. Cosmetics, okay, it is obvious. Cosmetics stands for cosmetics, yeah. Okay. Now, we come to the part to talk about the chemical data management system, which is an IT platform built by TÜV SÜD, yeah. And we will introduce the concept about the BOM-oriented testing and quantitative risk assessment. Yeah, the CDMS, as we mentioned earlier, we highlight that the future direction will be the chemical management and chemical data management. And we have seen and talked about what are the specific goals about the chemical data management. Now, next we look at the tools, look at the tool itself, that is a CDMS. And we would like to talk about how special the CDMS by itself. Now, in terms of the programming algorithm, there are four very unique features of this CDMS, and actually, TÜV SÜD already filed a patent on these features. Yeah? The first one is about an automatic bomb comparison algorithm. So whenever you upload a bomb, the first thing that's done by the system will be to compare with the existing data in the database to see if there are any existing results for a particular piece of material and list on this bomb. Or you could upload a batch of bomb, and then the system will automatically compare among this bomb to filter out those commonly shared materials. For those commonly shared materials and with some existing data in the database, we will take into the consideration of the performance of the suppliers. The system will recommend to you by what percentage you may like to retest on these commonly shared materials. This is first features on the algorithm side. Another feature is about it houses a mathematical model to allow you to compute the passing probability by chemical analysis down to a particular piece of materials of a particular suppliers. Yeah? And this probability calculation is not a static probability calculation. It is a dynamic one in the sense that you have a calendar of 12 months. You could prescribe a time window, let's say 3 months from Jan to March. You calculate the probability, let's say phthalates in a piece of plastic from a suppliers. And then you could shift this time window by 1 month, and then you could calculate this passing probability once again from February to April. The reason for doing so is to monitor the stability of your supply chain. Very often, as an end buyer, all you could reach is up to the tier 1. Let's say tier 2 is a factory supplier, tier 2 is a raw material suppliers. Anyone beyond tier 2 may be out of reach. But by monitoring the stability of this probability, you have the additional information of the whole supply chain. Last but not least, but actually the most powerful part of the CDMS is it could predict into the future. Right now, we evaluate the pass or fail by having the acceptance limit. Let's say in 6 months' time, the legislation body is going to change some of the limits. And then you would like to see, okay, let's say, for example, I'm going to change the acceptance limit of phthalates from 1,000 ppm to 500 ppm for PP in 6 months' time. Then you would like to know, okay, what will be the impact on my supply chain? If I'm not going to do anything on my supply chain, with this change in the limit, what will be the impact? Am I going to have any hotspots in my production? Hotspots means that is some materials are going to fail these new limits. Then this system will help you to calculate all this and pull out all the projects which potentially will have problems and allow you to do the budget to address these problems. So these are the 4 unique features in the programming algorithm of the CDMS. Yeah? Then we introduce the concept of quantitative risk assessment and sensible testing. What we are doing is we put down a mathematical model. We define a parameter called confidence level C. So with a confidence level equals 100%, that means every single requirement will be fulfilled in the next round of testing by your raw materials, by your final products. Anything fall below 100%, that means you have a certain risk in terms of probability to have a fail in the next round of the testing. And we know that this confidence level is a strong function of your testing parameter itself, that is ASO, phthalates, PAK, so on and so forth, and also the materials to be involved, as well as all the testing history with your testing partner. Yeah. Now, how we compute the passing probability, I try to illustrate this concept with a 2-dimensional risk array. And actually, you are very familiar with this kind of a risk array. On the horizontal axis, you could see that it is all about materials you are going to use in your production. Let's say it is electro fabrics, plastics, wood, paper, so on and so forth. And on the vertical axis, you have all the chemical parameters like ASO, SCCP, organotin, phthalates, PAK. Then what the system does is to populate this two-dimensional array with the passing probability. Let's say, for example, M1 stands for natural fabrics like cotton. P1 stands for azo. Let's say, for example, after testing 100 times from a piece of for cotton materials coming from a particular supplier, it failed only one time. Then in this system, we have a passing probability of 0.99. Of course, 100 times is too few in order to have a stable probability calculation. In the actual reality, we are talking about 10,000, 100,000, or even 1 million data points to compute this passing probability for you. And then at the end of the day, you could ask at least two valid questions. That is, what is the passing probability of a material supplied by a supplier A? Yeah. All the system does is to multiply all the passing probability under the column M1 to have the passing probability for that piece of cotton. And if we are asking about the passing probability of the whole product, all the system does is to multiply all the passing probability in each of the cells together to get the passing probability for your final product. Yeah? And if we generalize this idea further, instead of having the material and the testing parameter, we could have something like the sub-brands under a brand and the factories serving these sub-brands. Let's say, for example, for a sub-brand B1 under a brand B, the serving factories will be from F1 to Fi. At the end of the day, we could ask the question, okay, what is the passing probability of the factory F1 handle all the orders placed into it to serve the sub-brand B1? So right now we have a quantitative measurement on the performance of the suppliers. Then it goes all the way back to the KPI setting and the final quantitative measurement of the performance and the feedback of this quantitative measurement of the performance back into the BOM approach. So if you then after you grade your suppliers into different levels, then you could choose what is the percentage of retesting for your raw materials. This helps you to reduce the redundant testing at the same time to uphold the quality assurance along the whole supply chain. Okay? Then this CDMS, this is about the IT architecture of the CDMS. And also you could see this is also about the data flow between the different systems. I'm going to start on the left-hand side. On the left-hand side, at the bottom, you could see there's a system called LIMS, which stands for Laboratory Information Management System. Any non-food chemical testing lab nowadays should have this LIMS system in place. This LIMS system basically serves two purposes. One is for quality raw data generation, and the other one is for the quality control of the whole chemical testing laboratories. Because very often we will program the whole ISO 17025, which is the quality system of our testing laboratories, into the LIMS system. So with the raw data generated by the LIMS system, the raw data will be pushed to the CDMS. So that is how we turn the testing data into business analytics. Yeah, so you could have all the information like the risk calculation, what are the commonly shared materials between different BOMs, and even the Me-Too business analytics like, okay, how about my shipment day, the project already in the lab, or what is the current status of the testing, or even the financial data like what are the spending of a particular supplier under my umbrella right now with the testing house. And you could access all this information through a B2B portal, what we call the UCI. Yeah? And on the right-hand side, it is all about the internal hookup of this CDMS with our other IT system. The PSE is for project management. And then one thing worth mentioning, it is about the SharePoint of the TGRC information. TGRC is an internal unit of TÜV SÜD, stands for Technical Governance and Regulatory Compliance. The daily work of this TGRC is about the research work on any change on the regulatory limits and any recall cases. And in the future, all this information will be made available through the CDMS to the clients. Yeah? And there are four basic use on this kind of a risk, quantitative risk assessment. First one is about fixed budgets, because right now we have all the probability calculation, passing probability calculation associated with each of the testing parameters. And at the same time, for each of the testing parameter, for each of the point, we could associate the testing price. So we could take the testing point one by one until we hit your budget line. This will be very useful, in particular when you have a product produced repeatedly year after year, and you don't want to test 100% every single year. So this is a fixed budget. Another is the quantitative, quantified confidence level. As I mentioned, 100%, that means perfect, but actually in actual reality, we seldom have 100% in our production, even though nowadays we test on the final product, and very often these are golden samples submitted to the testing laboratories. It may not represent the general performance of the mass production. So we could, with the system, you could see with 100%, 98%, or even all the way down to, let's say, 80%, what are the difference in terms of the risk level and also the budget you are going to spend on the testing work. And then prioritization of testing materials of the testing in case of insufficient materials are very useful, because very often on the final product we have small amount of materials. And if we need to test according to your requirements, very often we have to knock on the door of the factory to have additional materials. And we see two problems with this practice. One is that the supplier may not have that additional materials or actually used for the production. It may just shop around to offer us the additional materials. And the second one, it is actually a nuisance to most of the factories to ask for the additional materials. So that is why we suggest to test according to the risk, on your raw material, on the materials, until we run out of the materials on the final products. The last part is very useful. Even though we have this IT platform, as I mentioned, we need to team up with this IT platform with a quality process in order to uphold the quality assurance program. And at the end of the day, we would like to perform spot testing on the final product. Let's say we would like to perform 10 spots. Then you could input 10 spots into this system, and this system will return which 10 spots you should go for. And how it could do this, it is based on the risk calculation I mentioned earlier. Okay? Now I am going to show some example based on this risk calculation. These are footwear products. We perform the test according to the CATS matrix. CATS is a working group in Germany, and from time to time they publish the testing requirements for footwear. And we could see in all these 4 examples, by taking 2% risk, that is move away from the 100% confidence level to, let's say, 97 point something percent confidence level, you could reduce the testing point around 15%. And this is a very significant saving. So what I'm going to do next is to show a 2-minute video on the actual IT platform, so you could see what it actually does. Before I switch to the video, I would like to do some very brief explanation first. Now you could see in the center of this IT platform, this is a screenshot. In the center of this screenshot, you could see an area at the top, which is about the project details. It is about the submission number, the TRF number. TRF stands for test request number, and also the lab you choose to work with, and also the supplier information. We could customize all these fields according to your requirements, because we appreciate the fact that different employers may have different requirements on the fields to be displayed on this platform. And then we have a list of all the projects. Suppose these are your projects at the moment. We have a list of these projects, so you could just click in to see the details of each of the projects. And on the left-hand side, it may be a little bit difficult for you to see now. It is all about the functionalities of this IT platform. I could read out some. One is about the system administration. This is the platform. This is the function where you could grant different access rights to your colleagues. Different groups with different departments within your organization may like to have a different access right. For the business colleague, they may focus more on the financial and also the business analytics. For the QM team or the QA team, they may focus more on the raw data. So different groups of colleagues may have a different access right. And then we have a function called bill of material. This is the functionality where you could upload the bill of materials in a batch form. And also testing request. This is an online application. You could put forward your testing request through this system. And in this video clip, I would like to highlight the functionality regarding the work list. This is where you could see how we apply the BOM approach, that is to filter all the commonly shared materials and then to cross-check with the existing of the data in the database, and then how we apply the second filter on the confidence level to eliminate further redundant testing. Yep. Okay, so now I switch to the video. Okay, so you could see right now I click into one of the projects, and this is the project with a sample for plastic and with from the suppliers. So we further click in, then you could see the work list. The work list actually is the bill of material or the material component list. And this is from grade B suppliers. And this is a very simple project, consists of only 3 material components, but luckily in the system we already have the results of the previous testing activities. And at the first glance, you could see the green traffic lights. That means all the data are good data with a very high passing probability. And then if you further click in, you could see that behind all the material testing packages, there are the testing parameters. For this plastic material testing package, it consists of 6 parameters, all with a green light. That means with good passing probability. Now we go to another example, which is a little bit more complicated. So once again, we have the project name. This is about a earring, and this is once again from a factory, which is a grade B suppliers. Yeah. Then we could see what is the impact to have these grade B suppliers. Now you could see we have the green traffic light and also the red traffic light. Of course, for the red traffic lights, that means we have to test again because previous testing indicate very poor passing probabilities. For the green one, we already have 3 passes in the system. And because this is a grade B suppliers, so the system suggests you to test for only 50%. So on the retesting column, you could only see 2 ticks for these 3 material components. Yeah. Now I'm going to play around with the confidence level. In order to show you the effect, I dropped the confidence level from 100% to 50%. And then, yeah, you will see on the sensible testing column, originally for each of the testing package, there is a nominal number of testing parameters. Now it all dropped to half of this nominal number of testing parameters. So this shows you how the system could help you to reduce redundant testing based on the BOM comparison as well as by the quantitative risk assessment. This comes to the end of my presentation. Thank you very much.
Thank you, Raymond, for this insight. So we hope that you found this session useful for you and interesting. So we have webinars monthly right now. So we encourage you to sign up for the Consumer Products and Retail Essentials newsletter at www.tuvsud.com/CPS. So you'll get the latest news, regulatory updates, and more information on webinars like this. If you have any other questions regarding the webinar topic or what we do, please feel free to email us at cps@tuvsud.com. So thank you for your time and have a good rest of the day ahead. Goodbye.